Okay, so today we're going to have some support material about the XGBoost, the coding. The XGBoost is just as I say, it's about a good performance decision tree algorithm, and this will be introduced by uh, the before for some competition. They got a better tree result, and I'm going to before that I'm going to introduce the two things about the trees, because the tree is a good way to describe our thinking in analysis for classification or do some prediction. And the trees like we got some node and the root that will divide with the separate results. And for some algorithm, they will divide in two, or for some algorithm, they divide in several. It depends on the results for our precision. And then this is the decision tree. Also, when the tree become more, and then this one kind of algorithm like a random forest. The random forest is with the different select trees to make some decision about what's the different status. So we pick one tree from forest to make one precision result, then we do it again. And the chart XGBoost is do the similar and the better trees pick on forest. So this is the XGBoost the difference from random forest. Okay, so you got my point about these three difference. The decision tree is just kind of one tree, and then when you got a lot of tree about a random tree, this means random forest. When you got the better optimization result, that will be XGBoost for fitting a better result. That's why XGBoost performs better in some competition. Okay, so how to do the XGBoost? That is become a question. So today I'm going to introduce this. But first, I already tell you how to get the package, and based on the package, you can import is the XGBoost is there's you can identify by yourself. Then the module will doing for select like the training and test speed. Also, you can doing course validation as well. Also, you can use in the boosting trick as the how to get the testing. So this is the package you can call depends on your situation. And I got the typical problem, typical way for you to do it. Then the scanner metrics we can use like the accuracy, recall, and precision. I have mentioned about how to evaluate. The accuracy means we find the better result with the decision. So because we got the two ways of the result was about the true or false, and then this depends on the true situations. So in the prediction, this is prediction, and the actual way, this might be true or false, and the true or false. If this actual is true, and then we predict true, that is good. So this is the A, is very good. If the actual is false, and the prediction result is false, This is good as well. D is good. And there's two kind of situations like type 1 and type 2 error before we have mentioned about. Today we're going to enhance the result, how to calculate the accuracy. Accuracy means it means the total result and what your have a better you correct the right one, and that means the accuracy. And also they have the precision. And the recall. There will depends on your situation to make the right decision, and the definition is I summarized here, and you can pick one up if, or you can compare these three metrics. You can easily to get what's the difference actually when you doing the experiments. And the precision means how we identify this one is true, and but this is actually is the problem is really the truth. So this is the A and A plus C. Okay, then the recall is the truly number you captured. This means the recall. So that is the A and the A plus B. Okay, this is difference because the problem. This metric is all important. It's depending on the situation, and this will be performed very good if you doing a good classification result. Because if you doing a good classification result, you got about this 100% of the true and to capture predict it as true. Then is the result is false, and you predict as 100% is false. That is the accuracy, precision, recall is 100%. But sometimes in the distribution of our decision is like a distribution. We need to define a threshold to find what's the to do the trade-off, because for some reason, just like we want to make sure better precision of the medicine needs, and we don't want to make a waste. So sometimes the precision will become more important than recall, and we can do in the trade-off. Got my point? If we want to capture all the patients, it will expense a lot, but it's very important, just like a big sick will become occur. So sometimes recall is more important than precision. Okay? Then, so based on these metrics, and we can have the classification result and to import as the result, like in terms of our situations. And for example, we using the same we have mentioned in IRIS about the data set is very traditional, and also is a very typical one, and we can easy to get the data. And then we load the data set, and also it's easy to get the load, and we need to identify the data and the data target, because the decision tree and the classification is we need to identify the target before we doing the analysis. So this is the result, and then we are going to spill the data into training and the testing. The training, we use the X training and X test. The training and testing result, we can use the several terms like, for example, I mentioned about how we divide into the training and testing. Is there the way we can use to identify what kind of training and testing? Like course validation, you know the course validation. For example, course validation we invited is a K4 course validation, and the K will become like 5 or 4, and you got you have you mentioned how what's mean is a 5 core validation. Well, it will divide into 80 and 20, that is 5-4 course validation. And how about 4 fourths course validation? It's 5, that means we divide in 5 parts, right? And 4, we divide into 4 parts, yeah? And 4 parts, that means training and testing will compare how's the percentage? $25 and $75, right? It's because the 4 part, right? 4 part for 1 part is 1 quarter. A quarter means 25. Yeah, 4 fourths course validation. And what I mentioned is another way is bootstrap. Bootstrap is we pick one sample up and then others with the training data. Bootstrap. So and there is a lot of areas that we can call out. So you just know how to do the spilled data. There are a lot of ways to do that. So don't worry about it, but what I mentioned is the usually typical way we use when we doing some experiments. Okay, then we using the test and the training for spirit with the test size. Test size means, so this is the 2.2, 0.2, that means 20% of the data will become the testing. Yes, and then there we can use the random state. Random state is just like the random state we are identified with the different data set. So that is the we can identify it in the code. Understanding? Which part? 哪里不懂 ？Random state 就在 random seed，random seed 乱数种子，乱数种子是什么意思？ That means because in the algorithm we identify the start point will be different, and if we don't set up the random seeds, that means the result might be the same in every time. 我们没有设定这个的话，那 that means we might face the same result as our classification. Okay? Because we are sampling the data, and we need to identify the random seeds. If we don't want to do this, we can use what I mentioned about cross validation. Cross validation, I can tell you more about the cross validation. Cross validation is a way to use the data in all more complete result. That means if we got the data, like just mentioned, we got 11,000 data. That's okay. That's good. And we use K4. The K4, that means we define the data with the K sets. For example, we usually, but not necessarily all the same. Usually we sometimes use the 5-fold cross validation. That means we have doing 5 experiments. The first experiment okay. We use the 5-fold. That means this is 5, right? And we got the 5-fold. For each time, the first time we use this part, okay. Good. Okay, the first time we use this as the testing, and the other fold will be the training data set. Okay, this is the first fold. Then the second fold, that means we use this part as the testing. The rest of the 4 part will become the training. And the third part, this is testing, fourth part, and the 5th part. And we can generate for these 5 times with the accuracy, recall, precision. We can have 1 number for each numbers. Oh, it's 2, it's 2, it's 2, and okay, so we got the result of each time, right? And we can have the training result, also the testing result, and we summarize to doing the average, right? And then this is the total result of this cross validation. So as the training result and the testing result is fine, then that means our cross validation is good. Got my point? So this is usually way we are doing some experiments. So that means for this just one result, we need to do it for 5 times. Okay? Any question? No? Okay, let's keep going. Then we can create the XGBoost model and the set parameters. The parameter will become, we need to identify with the, like the first is this is the XGBoost classifier, and our objective is the multi-sort mix, and then we use the classification of a number of classes, because is the data set for the iris is about 3. In different situations, we can identify with different classes with results, and then next tree depth. The depth sometimes 4 is that means we need to divide 4. This is 1, 2, 3, and we need to get another one. And usually 4 layer of the tree is very competitive. Sometimes is usually is the maximum of the tree we need to identify. If we doing too much, that will become overfitting results. So we don't want to have a too complex tree to describe the data. So sometimes 4 is very competitive, is enough for the terms. And the learning rate can be identified with the different terms, like how many terms you like is fine, because this depends on the data difference. So this parameter is very important for you to do different analysis, because for different analysis that will become the parameter you need to identify is with better results. So sometimes we use the optimizer, like some heuristic algorithm to identify what's the parameter is better. That's will more feasible when we doing this result. Or we need to do a lot of try to prove this parameter is feasible in this situation. So this is the very important part when we doing this kind of the research. Then we can only train the model, and train the model. Well, if we doing the cross validation, we use this more competitive results to find what's the average returns and what's this result is feasible or not, and we can use make predictions. Then this prediction is like we have the model for the prediction as the X about the testing, and this testing will make us to find which terms will become the better and in this situation. Then we evaluate the model about the accuracy, and what I mentioned, you can use the accuracy, or you can you can consider about the precision, also the recall, and then you can have this matrix and report the results, and also have the classification results for you to make the better prediction. And also the display the results, you can draw a lot of the table and also a lot of figures to more know the accuracy of and these terms we identify the accuracy. You can have printed out, and then also you can have this computation of matrix, and then you can identify what kind of the term is the relationship, and then we can identify which term is more important route to identify the data. Then we describe the data with more precisely, and then that means we have good results. And based on this result, we can consider, like for example, for this kind of routes, and then we can find out which term is have a more important term, like which characteristics is more related to our results. Then we can easily to divide the data with the different terms. Then and we can easily to describe the result and to better predict either in the classification, or we can use like the prediction like linear or some kind of the data for better prediction proof. That's will easily for us to control how we doing more flexible result. For example, the example about how to classification the iris, then we can know which term will be very key terms to classify it. Also in the NASA, we can easily to find the key term to predict the RUL, and then we can to make better prediction. Also, we can identify what kind of the height website, what's the term. Maybe we have see as a result this may be the update times, because the website is too old, you are easy to get hidden. So that is the several terms you can identify which the top is root will become your key terms. Then after that, you will based on your situation to find how to control and how to make a better, most optimal setting as a result. Okay, any questions? I will share it to you. Also, I update in our platform. If you have trouble with the access to the platform, also I will send it to you to our group, and you can try it after the class. And let me know if you have questions. Any questions? No. Okay. Good. Then.